Hello students, in this class we will study the operation of two-stage RC coupled amplifier, its frequency response, and also the calculation of cutoff frequencies, bandwidth of RC coupled amplifier. In the previous class we have studied the gain, bandwidth and frequency response of multi-stage amplifiers. So by the completion of this class you will be able to know what is an RC coupled amplifier, the working of RC coupled amplifier and its frequency response, and also you will be able to know why the gain falls at low frequencies as well as at high frequencies, and why the gain remains constant in the mid frequency region, and advantages, disadvantages of, and also the applications of RC coupled amplifier. And coming to important terms related to the amplifier are the gain, bandwidth and its frequency response. So you know what is a gain, definition of gain. The gain is the ratio of output electrical quantity to the input electrical quantity. Here the output of the amplifier to the input of the amplifier, whether it is the voltage or current or the power signal. So accordingly the gains are, we have different types of gains: voltage gain, current gain and power gain. So in general, when we talk with when we consider the RC coupled amplifier, it is the gain means it is the voltage gain or of the RC coupled amplifier. Coming to another important term, bandwidth of amplifier. Gain and bandwidth are very important terms related to the parameters of the important parameters of the amplifier. So by bandwidth we can define the bandwidth is the range of frequencies for which the gain equal to or greater than 70.7% of its maximum value. In between that range, where the gain is greater than or above 70.7% of its maximum value, those ranges of frequencies we call the bandwidth of amplifier. In between the two frequencies, the gain of the amplifier, RC coupled amplifier, will be more than or greater than or equal to 70.7% of the maximum value. Though in between that two frequency, all the frequency components in between the points where the gain is greater than or equal to 70.7 times of the maximum, all the in between the frequencies, all these frequencies in between these two points where the gain is more than or equal to 70.7 point of maximum value, all the frequencies gets amplified uniformly, and one more thing, the gain is greater at any in between these frequencies, the gain is always greater than or equal to 70.7% of the maximum value. So if we draw the frequency response, see the gain will take on the y-axis and frequency of the input signal on the x-axis, and it will be like this. So this is the maximum gain, A max, and at 2 points the gain here, this is the point F1 and this is the point F2, this is the input signal frequency. So if we draw the frequency response, gain on the y-axis it is the maximum gain A max. At one point the gain falls to at this point the gain falls to 70.7%. This is the point where the gain falls 70.7% of maximum of A max. These frequencies corresponding to this gain falls to 70.7% of maximum are known as cutoff frequencies FL, and this is FC. This point is corresponding to the gain when in the high frequency region where the gain falls to 70.7% of the maximum value. It is called as upper cutoff frequency FH, and this point in the low frequency region where the gain falls 70.7% of the maximum A maximum is known as the lower cutoff frequency. So this is called the bandwidth. The range of frequencies falling between FH and FL are known as the bandwidth of the amplifier, where all the frequency components falling in between FL and FC are amplified uniformly, and we call that this range we call it as the bandwidth of the amplifier. So this is the frequency response curve. What we have seen just now is called the frequency response curve. It is the plot showing the gain of variation of the gain with the frequency of the input signal. So here when we come to the operation of a RC coupled amplifier, so let us see the diagram of RC coupled amplifier. See here the RC coupled amplifier